Okay, so to find the volume, we are going to integrate from left to right. So if I'm going from left to right, what's the left x?
0.
0. What's the right x?
0.693147.
Yeah, something pretty gross.
0.698.
There's the x. It's this intersection. So I got to find out where that intersection happens. Sometimes that's easy to figure out. Sometimes it's not. So in this case, before you even turn to your calculator, I guess you could, whatever. But it's where e to the x meets up with 2, right? In terms of logs, where would that be?
Nope, not doing it.
No.
Nope.
The natural log of 2.
What? Just don't even try.
But go ahead and graph it and find the intersection. That's fine.
Wow, that's actually really impressive, man. 6.693.
14718.
It's on his calculator.
It's on my
I thought you were just spouting out numbers.
0.694.
I got it.
I feel like you should
Got it? Awesome.
Okay.
So
it's 4.
you want to use as many decimals as we
All
can.
right,
So what is it? 0.69 what?
314718.
That's
God.
That's all off the top of his head.
I'd give yourself 6 places, I guess. I mean, just give yourself a bunch and you'll be okay. So we're going to go from 0 to 0.693147. And we're going to go pi radius squared minus pi radius squared. What's the radius of the outermost circle?
2.
2. Good. And the radius of the innermost circle?
E to
E to the x. Yay!
Wait. Oh, yeah, that's right.
Then you take out that pi.
Take out the pi.
Whoa.
And we're going to do 4 minus e to the 2x.
Okay.
All right.
That's a little scary. I thought maybe we should set up a decimal.
It's a little scary.
It's a little scary.
It's a little frightened. I'd be scared too. No, it's wrong button. Point 69314.
Let's get confirmation.
Why is it? God.
Then you gotta put a pi.
Oh, thanks. Yeah.
What did what?
I don't know. That's
Doesn't
what.
want to get that.
Is that right?
Yeah.
1.272. 1.273.
Yes, I got it right.
272.
First.
Well, actually, a second, I got the other part right as well. 0.69, whatever.
Nice.
One roll.
Oh, I guess we're truncating now. All right.
Whatever. You're gonna be that way. Okay. Feel confident? Here's where your confidence gets shattered. Oh.
Woo!
Just kidding.
Excited.
Okay, so we take it kind of slowly. Now we're gonna go y-axis. So let's take x squared.
I feel like this subject just shows me how bad I am at drawing. At drawing geometrical figures.
I still can't draw a box.
You can't fill a box.
Yeah, Alexa has to draw my boxes.
It's the secret
They're
reveal.
kind of curved.
Is it a box?
Dude, it's the secret reveal. Just wait.
Alexa,
What?
is it a box or a question?
It's like a box, like a cube, a box.
Okay.
Draw a square.
Congratulations.
I can draw a square. I mean, they let me out of kindergarten.
I color in the line.
That's sometimes, most of the time.
It's 2 squares and you just connect lines.
Unless I'm feeling rebellious.
It's
Color in
more
the line.
difficult than you would think, because she likes to have it on an angle because it makes it more, and she thinks that she tries to make the corner in the front. You don't understand.
I remember elementary art school. Elementary art school. That's
Elementary
what I
art
went to.
school.
No, elementary art school. That's what I went to.
That's
Good stuff.
Okay, so really easy curves. Let's graph it. We've got y equals x squared. I mean, I'm 5 and x equals 0. I guess I should have said this could have been either of these areas. It would say in the first quadrant. Because if I draw y equals x squared and 5 and 0, I've actually got two different bounded areas. So let's just take the one in the right quadrant, even though I'm going to end up drawing its mirror image in just a second. So this is the area I've got.
Would it be the same if it was on
Yep.
both?
Say it again. Yeah, I guess it would be this. If it was the whole thing
Yeah.
and it was just, it would be the same thing, yeah.
What? There's nothing wrong with that.
So you're going to revolve this around the y-axis. So when you revolve it, my first question is, does this have a hole in the middle or no? No. Okay, because there was no gap between the curve and the y-axis. So when I go around, this is like a solid. This is just literally a dome. In fact, isn't this just, well, it's not a half circle, but it's almost a half circle.
It's a half sphere.
It's half extra.
It's just that the y equals x squared isn't a circle. So
That's
it's,
close.
it's like almost kind of half a football-ish.
It's a little oblong.
Yes.
Just use
But
that
so
word a
here's
lot.
the difference. My cross sections are horizontal this time
This is oblong.
instead of vertical. So I am not going to integrate from left to right.
That's it.
Here's my circle, and here's the radius of that circle. So here's the thing that sucks.
You can't use a calculator?
No, you can, but everything needs to be in terms of y, first of all.
Everything.
So for example, what I mean by that is, instead of y equals x squared, we're going to consider that curve to be x equals the square root of y. Yeah. Okay, everything's got to be in terms of y. So every function I get, I have to solve it for x, so that I'm looking at the variable being y. The second thing so this curve here, instead of this thinking about it as y equals x squared, this is x equals the square root of y. In addition, instead of integrating from left to right, any clues how I'm going to integrate this time?
Right to left.
Bottom.
No,
Bottom to top.
bottom to top. Okay, I'm going to integrate from bottom to top. So from the bottom y to the top y, everything's changed now. So before, if I'm going around the x-axis, I'm integrating from the left x to the right x, and everything's in terms of x. If I go around the y-axis, I want the bottom y to the top y, and everything's in terms of y. So I kind of am thinking about this still as pi r squared minus pi r squared, if there was an inside. But this should be like, just think of it as like the outer circle and the inner circle, which is the same way you thought about it before. But now it's just horizontal instead of vertical. So in this case, what's my bottom y?
0.
0. Okay, this started here at 0, 0. And I'm stopping here at 0, 5, or I guess I can, sorry, over here at whatever that is, 25. No,
That would be
square
required.
root, yeah, root 5, 5. But all I need is the y value. So I'm going from 0 on the bottom to 5 on the top. And I've got pi times the radius squared. There's only one radius to worry about. I don't have an inner part, I only have a main part. So the square root of y. Squared, pardon me. That's it. So this is going to be pi. Tim's going to integral from 0 to 5 of y. Technically, I can put that dy with it. You can use your calculator. This is also super easy to do without a calculator. This is just y squared over 2. So it's 25 halves pi. Do it.
How would you
And
want
you
to
could,
do that?
yeah, would you?
Oh, just use x's. Yeah,
just
it's going to give you the same thing. Yeah, so when you put this in your calculator, you can just use x's instead. Is that okay? Let's do one more that has a hole. Let me find one that's going to work well. Oh, that's good. only way it gets harder than this is we're going to revolve things around the line like y equals 2. But not today. We'll do that tomorrow. Definitely, like, don't skip the homework tonight. You want to make sure that you're pretty comfortable with this before you come in tomorrow, or it'll be just like adding that next layer on, and it'll just get that much harder, that much more confusing. Try to sketch this. It's a parabola, it's up 1. It's terrible drawing. Y equals 0 is this. X equals 0 is this. X equals 1. What the? What the? Oh, is this? Oh my gosh, it was 1. I'm going to draw this bigger, just so you can see better. Okay, so you've got x equals 0, x equals 1, y equals 0 here, and y equals x squared plus 1 here. Is that okay? Alright, I'm going around the y-axis. So what makes this a little weird?
So a hole in it?
There's a hole in it, but it is not in the whole thing. The hole is only happening here and above. Down here I don't actually have a hole as I go around. So this graph is kind of weird. And we're going to split it into 2 parts. Let's see, where is this at? This is at 1, right?
Yeah.
Below 1, what kind of shape gets made when I just take this line and I revolve it around?
Cylinder.
A cylinder. It's just a cylinder. I could actually use a cylinder formula to find the volume of this part. Or I can just integrate from 0 to 1. What am I integrating? What's the radius of this circle?
1.
Radius of the circle is just 1. So I'm integrating pi times 1 squared. So the first part of this problem, remember I'm integrating from bottom to top. The bottom y is 0, the top y is 1. So this orange section is just a big cylinder. I could just, the volume of a cylinder is pi r squared times h. This could just be pi r squared times the height. I could just do it this way. This is the volume of a cylinder. This is the integral. Either way is fine. I'm going to get the same exact answer. I can either just integrate the pi r squared, the radius of 1, or I can actually use the volume cylinder formula. It's totally up to you. Because we're kind of in the mind frame of integrating, I would probably just use this. But it's up to you. So from bottom to top, from 0 to 1, pi r squared, the radius is just 1.
Rhyme.
What's that?
Rhyme.
What did you say?
You rhyme.
Oh, it did. I didn't mean to. I read too much Dr. Seuss this weekend. The second part, now it's going to go from 1 to what? Bottom to top. Where's this?
Dose.
Is it 2?
Yeah.
Yeah, cool. So now I just have to go from 1 to 2. But now I've got an outermost curve, or circle, sorry. And I've got an innermost circle. So I've got to take the one radius and subtract the other. So it is pi times the radius squared minus pi times the radius squared. What's the radius of the outermost circle?
1 x squared plus 1.
It's just still 1. Okay, the radius, it's not the x squared plus 1. The radius of the outermost circle is this orange one. takes me to here. Well, what's here? It's that one. Now the black one, the radius of the innermost circle, is taking me to that curve. Well, what's the problem? I can't leave it as x squared plus 1.
It says root y.
Yeah, I gotta go change this to x equals y minus 1 square rooted. It's just whenever I rotate around the y-axis, I've got to put it in terms of y. So it's just a ton to put in your calculator. But I do have the answer. Make sure you get it. I got 1.5 pi for the whole thing. This part from the beginning of the cylinder without the hole, and then this part all together. I think the biggest thing you gotta do is be careful and like draw it, and just try to follow the procedure and try not to screw it up.